As we've talked about the three angle bisectors in a triangle and how they intersect to form the incenter. We've also talked about the three perpendicular bisectors, how they form the circumcenter, and then the three altitudes, how they form the orthocenter. So today we're going to look at what about the three medians. So if we take the medians of a triangle, what happens or what occurs? So you are in your group, and we're going to go through these steps. If you want to follow along your group, it's the same investigation. It is on page 185 for those of you that are watching, okay, at home. And so it said each person in your group should draw a different triangle for this investigation. So I've already put you in your groups. Okay, make sure you have at least one acute triangle, one obtuse triangle, and one right triangle. So you're in your groups of three. Okay, one acute, one obtuse, and one right. For those of you, if you're at home or you're watching this video, you can always use wax paper. Just pull out some of that. It doesn't have to be in the shape of a square. Okay, but go ahead and draw that. You guys, one of you guys can do okay. So one. I have an obtuse angle. I got the right. Okay, so you guys both have the acute then. Okay. So on a sheet of patty paper, it says draw as large a scalene triangle as possible and label it C and R. Okay, scalene means what about all your sides? They're unequal. So make sure you don't have any sides that are the same. Okay, so you might want to make sure you don't have any sides that are the same. So we need an acute, an obtuse, and a right. And they all have to be scalene? Yes, all scalene.
Okay, I got it.
Oh, hit my. Label it C and R. Okay, label that C and R. Now remember, those are the vertices of the triangle. So kind of as they're in the diagram. Now it says locate the midpoints of the three sides. So remember to find the midpoint of a triangle. Remember, you fold that triangle on itself and you match endpoint to endpoint. So first of all, you could just match up C to N. That will give you the midpoint of that side. Just do a little crease there and mark it with a dot. Okay? And you're going to do that for all the three sides. Now you don't necessarily have to make a long crease, just a little crease as to where that dot is. So what's going to happen is you're going to have a picture like what's up here in the blue box. Okay? So that should be done. You should have 3 dots when you're done. Now once you get those 3 dots done, I want you to go ahead and draw the medians in. Now for those of you that are kind of confused, all right, because it does happen, all right, this is what you're going to do. You're going to start here at C, and you're going to draw up to that point, okay? Then you're going to come over to this other one, to N, and you're going to draw up to that point. And then you're going to go over here to R, and you're going to draw over to that point. So when all is said and done, you're going to connect. Okay, so you're going to start with a vertex, draw to the point on the opposite side. Yeah. Okay, it needs to be on the segment. You need to do this on the segment. So you're going to put a dot right there. Okay. You're going to do the same thing with each of the sides. You should have the midpoint of the side. So this one, let's see what the dot there. Yeah, so you're going to put a dot right there. You're going to put a dot right there. Take a vertex right there. That is this point. This to that point. So what do y'all notice about the three medians of a triangle? They all meet, they all intersect. So in other words, remember we used the word they are concurrent. Okay, so that's the median concurrency conjecture. The three medians of a triangle are concurrent. Now, that's why you did three different triangles, because if you notice, it worked in an acute, it worked in a right, and it worked in an obtuse. Now, we actually have a definition that you probably better get down, and that's the centroid. The centroid is the point of concurrency for the three medians of a triangle. So now we're adding that to our list of the incenter, circumcenter, and orthocenter. This is the centroid. It is a point of concurrency for the three medians of a triangle. So actually, if you would want to even label your patty paper centroid, because then that way you've got your other three as well. That way you kind of know what that one is. So now what I want you to do, notice what it says. Label your three medians, C, T, N, O, and R, E. So just like this, look at the blue box. The blue box will tell you. Okay, C, T, N, O, R, E, label the centroid D. Okay.
I have a link packet.
So C, T, N, O, and R, E, label the centroid D. Now it says use your compass, and that's what I want you to do. I don't want you to use another sheet of patty paper, to investigate whether there's anything special about the centroid. Okay? Instead of using your compass, I want you to use your ruler. Or those of you that have your protractor, use the measurement side. Is the centroid equidistant from the three vertices? That's the first thing I need you to check. Then I need you to check, is it equidistant from the three sides? And then is the centroid the midpoint of each median? So you have three questions here. So first of all, is it equidistant from the three vertices? Then from the three sides. Then the midpoint. So is it equidistant from the three vertices? Okay, no. Is it equidistant from the three sides?
No.
Nope. Is it the midpoint of each median?
No.
No, so we have three no's. Okay, so now let's go ahead and look at this next step, step 4. The centroid divides a median into two segments. Okay. Focus on one median. So it doesn't matter which one, pick one. Use your patty paper or compass, you're going to use your ruler, to compare the length of the longer segment to the length of the shorter segment and find that ratio. Okay, so pick one of the medians. I want you to measure the longer segment, and then I want you to measure the shorter segment and see if you notice something between those two. So now if you're a little unsure, because the measurements, move to one of the other medians and try it again. Measure the longer segment and then measure the shorter one.
I would simply input. Like here, 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 here.
Oh, I
What do you notice?
That the short is double, or is half of what the long one is.
The short is double or half of what the long one is. Okay, so the short is going to be half of what the long one is. So an example would be, if in this diagram up here, I knew that this short segment was 1 inch, this segment here has to be what? 2 inches. Okay, if I knew here that this long segment is right here 4 inches, what would this one right here have to be? 2. Okay, so you're going to utilize that information on today's homework. The shorter segment is half of the longer segment, or you could view it as the longer segment is double the shorter segment. So we have a centroid conjecture. The centroid conjecture says the centroid of a triangle divides each median into 2 parts, so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the opposite side. Now, have you ever talked about center of gravity in science?
No.
The center of gravity is actually kind of like the balancing point of an object. Okay, so if I had a line segment, the center of gravity would be the midpoint. Okay, that is actually where you could like take your pencil and you could balance that line. And so in a triangle, we actually have a point 2. That if we take the tip of our pencil and we try to balance that triangle, we could actually balance it. And that point is actually known as the centroid. So if you were to take your patty paper and maybe put it on a harder sheet of paper, okay, and you wanted to balance that triangle, you could balance that triangle on the tip of your pencil if you place the tip of your pencil at the centroid. That is called the center of gravity. So the centroid of a triangle is the center of gravity of the triangular region. See, the thing is, you've actually got a square sheet of paper. You can't do that technically like right now. You could if you would cut it out. Okay? Because where you're balancing it right now is not the center of gravity of the paper. It's the, so, okay. All right, so let's refresh and let's talk about a few things. You don't necessarily need to write this down. Okay, it says you've discovered special properties of 3 of the 4 points of concurrency. First of all, the incenter, the circumcenter, and the centroid. The incenter is the center of an inscribed circle. Okay, so the incenter right here, I could inscribe a circle in that triangle. The circumcenter is the center of a circumscribed circle. So the circumcenter here is that circumscribed, so that bigger circle. And then the centroid is the center of gravity. Now there are some qualities about the orthocenter too. We're just not going to discuss them. So what I need you to do is I need you to add these 4 problems onto the end of section 3.7. Section 3.7 was page 182. So don't start a new sheet of paper. Okay, just go ahead and add these 4 to the bottom of your lesson from section 3.7. Now remember, we're looking for your assessment to probably be Wednesday and Thursday. Now, we'll talk more about that tomorrow, but your assessment for chapter 3 is going to be probably those 2 days.
47.